Hello, today we're going to study the binomial expansion with fractional or negative exponents. So, binomial expansion is not very difficult. You basically apply this formula, which is a plus b, remember that plus could be a minus, to the power of n equals n over 0, a to the power of n, b to the power of 0, plus n over 1, a to the power of n minus 1, b to the power of 1, plus n over 2, a to the power of n minus 2, b to the power of 2, plus, and so on and so forth. And I remind you that n over k equals n factorial divided by n minus k factorial divided by k factorial, which means n times n minus 1 times n minus 2 times, and then when I go downwards, as k is less than n, we're going to basically get n minus k times n minus k minus 1 times etc. Okay, and now I divided this with n minus k factorial, which is n minus k times n minus k minus 1 times n minus k minus 2, and so on and so forth, and then k factorial, which is k times k minus 1, etc. If you take a look at this part over here is going to be n minus k factorial, the same that we have here. As I said, because n is going to be always greater than k. So you can basically divide that into that, and we're left with n times n minus 1 times n minus 2 times up to until when? Not n minus k, but n minus k, the next one, so which is n minus k plus 1. So it's n minus k plus 1 divided by k factorial. Okay, and this is the formula that you need to use in order in the negative and fractional exponents, because it's the one that is easy to use, and not the previous one, not this one over here, because it's very difficult to use that one with negative and fractional exponents. But this one is easy, as I'll show you now. I'm going to give you an example with numbers so that you take a look at, you can understand what is happening. So we have, I don't know, 9 over 2. Okay, so you're going to have 9 times 8 times 7 times 6 times 5 times 4 times 3 times 1 times 2 times 1 divided by, and now we're going to have 9 minus 2, which is 7 times 6 times 5 times 4 times 3 times 2 times 1 times 2 factorial, which is, I'll leave it as that. And as I said, this part over here, you already have it over here. Okay, so you can divide that, and you're going to have 9 times 8. Why do we finish in 8? Because it's n minus k plus 1, which is 9 minus 2 is 7 plus 1 is 8. So we finish in 8 divided by k factorial, which is 2 factorial. Okay, so this is what we're going to use in negative and fractional exponents. Let's do a pair of exercises, one of each. So imagine we want the first 4 terms. It's always going to be the first 4 terms in the ones I'm going to show you. It might not be in your exam. First 4 terms. But with the first 4 terms, we've got more than enough to show what is happening. Of the expansion of square root of 9 plus 3x. First of all, a word of advice. I always recommend you, well, let's write this like this. And the word of advice is, I always recommend you to factorize whenever you can. It's going to make the exercise much easier. I'm going to do this exercise without doing the factorizing, and the next one with the factorizing, so you see that the next one is going to be easier. But so that you see that you can do it both ways. What I mean by factorizing is that you can write this as if we factorize 9, it's going to be 1 plus x divided by 3. Because if we factorize 9 there, we have to, 9 divided by 3 is 3, which is the one we had here, okay? To the power of 1/2. And then we can extract this as 9 to the power of 1/2 times 1 plus, sorry, I'm already thinking of the next step, which is 9 to the power of 1/2 is square root of 9, which is 3. So this would, if we did this, it would mean doing the expansion of 1 plus x divided by 3 to the power of 1/2. And this expansion with the 1 here is always easier. Why? Because all these terms of a to the power of whatever are going to be 1. Because 1 to the power of whatever is 1. And it's going to be much easier. But as I said, I'm not going to do it like this. In this case, so that you can see, you can obtain the same result. Either way, I'm going to do it without the factorizing. Okay. So, let's start with this. So, the first term, I always like to write this here, down here, so that I know where I am, is 1/2 to the power of 0. 1/2 over 0. This numbers where you have something over 0, it's always going to be 1, by definition. That's 1 times 9 to the power of 1/2 times 3x to the power of 0, plus, now I'm going to do 1/2 over 1. And 1/2 over 1 is always going to be the number on top, so the half. So that's going to be 1/2 times 9 over 1/2 minus 1 times 3x to the power of 1 plus 1/2 over 2. This is going 1/2 over 2. This is the first one that I need to explain. Okay, so bottom part, as we said before, is going to be 2 factorial, which is 2. 2 factorial. Now, this is going to be 1/2 times 1/2 minus 1 up until when? Up until n minus k plus 1. N minus k plus 1 is 1/2 minus 2 plus 1, which is 1/2 minus 1, and that's the term I have here. So I can finish here, okay? I can always check it like that, but I tell you in advance that if you have something over 2, you're always going to have 2 terms multiply. So that's going to be 1/2 times 1/2 minus 1, which I'm going already to write it as minus 1/2, okay? So those 2 terms multiplying, and then divided by 2 factorial, which is 2. So that's going to be divided by 2. Times 9 to the power of 1/2 minus 2 times 3x squared. Okay? 1, 2, 3, 1 left, which is 1/2 over 3. Okay? For the same reasons, this is going to be 3 factorial, which is 6. 3 times 2 times 1 is 6. Over 1/2. 1/2 minus 1, which I've already said minus 1/2. 1/2 minus 2, which is going to be 1/2 minus 2, is 1/2 minus 4/2, which is minus 3/2. And I'm going to stop there because, as I said, when it's over 3, it's 3 terms multiply. You could do it the other way, doing n minus k plus 1, and you see that you have to stop. Times 9 to the power of 1, 1/2 minus 3, times 3x to the power of 3 plus, okay? So, let's go on with that. Let's simplify. 1 times 3x to the power of 0, which is 1, so that's 1. Times 9 to the power of 1/2, that's square root of 9, which is 3. So the first term is 3, plus. Now, I'm going to write 9 to the power of 1/2 minus 1 as 9 to the power of 1/2 times 9 to the power of minus 1. I'm going to leave the 9 to the power of 1/2 on the numerator and put the 9 to the power of, so I'm going to leave that as 9 to the power of 1/2 is square root of 9, which is 3, and then 9 to the power of minus 1, I'm going to write it as 9 in the denominator, okay? So that's going to be 3 divided by 9. Remember that I had a 1/2 before that, so a 1/2 here, okay? And then I have a 3x to the power of 1, which is 3 times 3x. Okay? Scrub that out. And I'm going to simplify now, so which is this over that, and that's simplified. Oops, careful, not the x. Yeah. Okay, so I have a half times minus 1/2 is minus, so I'm going to have a minus here, and I have 2 times 2 is 4 times 2 is 8, so I have 1/8. 9 to the power of 1/2 is 3. 9 squared, I'm going to write it in the denominator, and then I have 3 squared x squared. Okay, so that's 9 squared on the denominator, because 9 to the power of minus 2. So this is 9, with this one goes away, and this one is a 3. Okay, and then I have plus. I'm going to do the same thing here. I have 1, 2, I have 8 here. Minus and minus is plus, so I have a plus. 3, 6, another 3, because of the 9 to the power of 1/2 on the numerator, 9 to the power of 3 on the denominator. Then you have 3 cubed of this one, and x cubed. Plus, okay, so that's 3 plus x divided by 2 minus x squared divided by 24 plus, let's see what we get here. So this one is a 9, with this one leaves a 2. This is 3. If I simplify this, I get a 1 here, and I can leave this as a here, so I have 3 here, and I have 9 here. The 3 with this one gives a 2, so it's 6 times 2 is 16 times 9 is 144, and that's x cubed plus. Okay, so that's the fractional one done. But as I said, a lot of numbers there, you have to be careful not to make mistakes. So we're going to do the first 4 terms of the negative exponent, and you'll see that I'm going to factorize, and it's going to be easier. So, okay, so let's factorize here. I want a 1 there, so I'm going to factorize the 2, 1, 5x. And then you have 2 to the power of minus 2. I'm going to write it already like 1/4. I hope you followed me there, but this is the expansion that I need to do. Okay? So I'll write the 1/4 here, and I'll start. It's, remember, minus 2 over 0, which is 1, times 1 to the power of minus 2, times 5x to the power of 0. First one done. Plus minus 2 over 1, which is minus 2, as I said, times 1 to the power of minus 2 minus 1. I don't care, that's going to be 1. Times 5x to the power of 1 plus minus 2 over 2. And that's going to be 2 factorial, which is 2, minus 2 times minus 2 minus 1, which is minus 2 times minus 3. Okay? And as I said, 2 terms. So that's going to be plus, well, I'm going to write minus 3 here. Okay? Times 1 to the power of minus 2 minus 2 times 5x to the power of 2 plus, and the last one, minus 2 over 3, which is going to be 3 factorial on the bottom, which is 6, minus 2 times minus 3 times minus 2 plus minus 2, which is minus 4. Okay? And as I said, 3 terms, because the bottom number is 3. Times 1 to the power of minus 2 minus 3 times 5x to the power of 3 plus. Okay? Then we have, let's simplify. That's 1, and that's 1, so that's 1 here. whenever we expand 1 plus something, we always get the first term as 1. Now, it's a negative because we have minus 2 here, so minus 2 times 5 is 10. And 1 to the power of whatever is 1, so I'll leave it like that. Minus and minus is plus, so this one is plus. This one goes away, and we have 3 times 5 squared is 25. So we have 75. And then we have minus minus minus, which is minus. And then if we simplify here, and that one goes away, so we have 4 times 5 cubed, which is 500. And then we have x to the power of 3. And those are the 4 terms. Okay. So, so that's it. We can now multiply by 1/4, but there's no need. Okay, and as you can see, this one was much easier than the one before because we factorized first. So, as a conclusion, always use this second formula for fractional and negative exponents. It's much easier and faster, and you can understand it much better.